Here, I'm going to talk about visualizing uncertainty with hypothetical outcome plots. I just tweeted my slides, so you can find me on Twitter at Claus Wilke, very easy to remember, just my first name, my last name. And I'm going to talk about, it's kind of an experimental package, which you can find here at this location. And again, if you find the slides on Twitter, that will be the easiest to find all of that. Okay, so to motivate that, let's look at this extremely original plot. It's of cars, you may have heard of it. We did not coordinate this. So fuel efficiency, miles per gallon, in this case plotted versus displacement of the engine, and you see it goes down, and I fitted a nonlinear model here, and I'm sure you have seen plots like that. So you have this line that was fitted, and then there's this gray band, and that tells us something about the uncertainty of that fit, right? Every time we model something, there's uncertainty, and we are used to displaying it like this, but what does that actually mean, right? The truth is most people don't know, like I don't really know. Nobody knows, but it has to be there, because if it's not there, you get complaints, right? What's your uncertainty? Oh, there's a band, okay, now I know. Okay, what that really means is that, I mean, this line is just one of multiple ways that we could have fitted it, and so there's really an ensemble of different possible lines, right? We could plot fitted draws, and that's not bad. The fundamental problem, though, is if we have the fitted draws, okay, there's a line that goes here, and then there's a little gap here. So does that mean the line would never go here, right? Can the line ever go here? So you don't know, right? And the problem fundamentally with uncertainty is that you don't know, but when you see a plot, it looks certain, right? It's really difficult to plot uncertainty because the plot is kind of certain, but it's not certain. And so there was this idea that was popularized very recently of the hypothetical outcome plot. Was this paper +1 2015 by Jessica Hullman, which is to actually animate, to cycle through different potential fits, and that to some extent reduces this, because it's not static, it's more clear that these are alternatives and you don't really exactly know what it would be, but it's something like that, right? So it's a much more intuitive way of thinking or of experiencing the uncertainty. Okay, so last August, Hadley tweeted, hypothetical outcome plots are a great way of communicating uncertainty to non-experts. And then he put forth this challenge. Someone should make an RStats package to make these easier to create. Would be easy on top of gganimate. Famous 3 words. Okay, so I was thinking, I've done a lot of work with ggplot lately, and I really like gganimate, and I thought, well, maybe I can do that, let's see. And so what I'm talking about today is really my discovery of what are the useful things that maybe a package could contribute in this world. Okay, so there's really 3 questions that Hadley's challenge poses. So the first one is, how do we generate the outcomes? There's many different ways that they could be generated, so it's not trivial. Once we have them, how do we get them into ggplot? I'm just assuming we do this with ggplot, right? gganimate, though of course you could use some other platform also if you wanted to. And the last one is there anything to be done? And you'll see in a second why that is actually a meaningful question. So is there anything to be done? Immediately after Hadley tweeted this, there was this following response. You can make them easily with tidybayes and gganimate. The hop examples in this talk were done that way. I'm adding examples to the tidybayes vignettes when gganimate hits cran. Okay, done. Problem solved. Well, okay, so this goes to how do we generate outcomes, right? So we can do Bayesian MCMC sampling. That's what the tidybayes does, and that's great, but not everybody is a Bayesian, right? Or maybe like in some models, it just takes too long to do MCMC sampling, or whatever the reason is, you may want to do other things. So maybe you want to bootstrap, right? Resample the input data. Or maybe you want to fit a regular regression model and then just sample from the normal approximation to the uncertainty distributions that you get, right? So we could argue that this is done with tidybayes. It's very natural in the Bayesian framework to get these fitted draws that then you just somehow get into gganimate, but the other two still need some work. Okay, so let's look into bootstrapping. So actually, Alex Hayes' talk at the beginning of the session, if you were here, was actually the perfect introduction to my talk, because he explained why I was unhappy with bootstrapping. What he did to bootstrap was terribly complicated, right? Was a lot of work, which is fine if you have a sophisticated bootstrapping setup. But I don't want to do that. I just want to do a few bootstraps to plot, right? Okay, so what I did is I bugged some people, and the person I mostly ended up bugging is David Vaughn, who sits right here, is running this. And I said, we need an easier way of doing this. And so that's coded now. It's not yet really released, but it's going to be an R sample eventually. And it works as follows. So if we take, say, the iris data set, we group it, and then we bootstrapify. It's the magic word. Does the following. If you know the iris data set, this is the iris data set, nothing has happened except this now in groups, it's species. I've grouped by species, and it says bootstrap 15 because it's 3 species and we've bootstrapped each 5 times. So it's this virtual bootstraps that we've generated that we can use in a dplyr sequence. So now we summarize, we calculate the mean sepal length, for example. And now the output, we get 5 numbers out here because we have 5 bootstraps and we have the mean length. So that's about the level where I feel comfortable with. That's easy enough. I can live with that. So now we can think about how do we get this into ggplot, right? So let's say this is our static plot without any bootstrap. And so now we have to bootstrap, right? I make a bootstrapped data table, I bootstrap 20 times here, and this gives me the name of the key column, so which I group here, and so I get bootstrap plots. Okay, that's fine. It's still not easy enough. And so this is where I thought a little harder, and I think we can do it even easier. And so the problem here is, which I fundamentally dislike, I'm piping the data into the plot, but I'm sticking other data into the plot again, right? And so if I want to do anything here in the pipe before I put it into the data, then I also have to change this, and it's just too complicated, right? I want to bootstrap in the plot. Now I could start writing all sorts of special layers like geom, bootstrap, smooth, or whatever, and I end up writing a new layer for each type of geom or stat you have, and that's also too complicated. So I came up with the following idea, which uses a very little known feature from ggplot. And so this is this library ungewiss that I wrote. The German word ungewiss means uncertain, so it's like a play of words. If you're German, you understand it. That's the website. I'm German, as you probably guessed by now. Okay, so this is what it does, right? The key line is this line. So you can actually, in ggplot, as data, give it a function that then does something to the data. And so Bootstrapper creates this function, and there the 20 is the argument of how much do I want to bootstrap. And so these 6 lines of code generate this, right? And so now you see I feed in the data once, I plot points, so the points are just the original data set, right? And the geom smooth, I bootstrap. And that's how I get these bootstrapped lines. And then, of course, I can connect that with gganimate. So if you don't know gganimate, it's this really nice way of animating plots. So this is the only additional thing that I need to do. I say I want to transition between draws. And then these 2 numbers are just how long do I take to transition? I transition instantaneously. How long do I stay in the state, and the 1 is then meaningless. It's just they all stay the same amount of time, and I get this nice animated plot. Okay, let's do another example just to show you so we can do different things. We don't have to do just smooth regression lines. So chocolate bar ratings, this is a data set. Each dot is 1 chocolate bar rating, and the orange dots are the mean, just to show you on average. So here we have USA, this kind of similar to other, and then Canada, on average, has a higher rating than the US, right? But there's a lot of US ratings, not that many Canadian ratings. So we might want to know, does a randomly chosen Canadian chocolate bar taste better than a US one? So that's a common language effect size. We just take one US chocolate bar, one Canadian chocolate bar, and we say, which one is better? So the blue lines that are jumping there, those are the two bars, right? You go in the store, you buy two bars, and then you go, which of the two is better? And as you can see, it's sort of even. The exact percentage is actually 53% of the time Canada is better, and 47% of the time US is a draw or is better with Canada. And you kind of get that, right? You see from the jumping dots, like it could really come out either way. Okay, so how do we do that? So now we don't have to bootstrap, right? We now have to sample. And so David Vaughan also wrote code for sampling, and I piggybacked on that and wrote a feature to add that to ggplot. So we start with our data set here, the COCO data set. We only take Canada and the US. So this is an example of how we may want to process the data set before we feed it into ggplot, right? Rating and location is what we want to plot. First, we plot a cloud of all the ratings, right? That's just a geom point. And then I invented this geom, which I think is needed, and nobody had done it, I think. If somebody has, tell me, and I'll delete it from my package. Call this a vertical point line. It's like a point, but it's a line, right? And so this is now here the key thing, data. Now instead of bootstrapper, I do sampler. I sample 25 times. But I actually have to group, because I don't want to sample from the entire data set, right? I want to sample individually from Canada and the US. What I haven't specified is my sample size. By default, it's 1, but I could sample different sizes. I could sample 10 or whatever, right? The group is really important. If you don't specify the group, you might end up with 2 US chocolate bars and no Canadian one, and that wouldn't work. Okay, and then in the end, oh yeah, this is just a little trick you need to know. If you don't do this, then the lines, they tween, so they move smoothly from one to the other, which looks nice, but is actually, for perception, is not that great of a choice, so it's better to turn that off. And then again, we animate, and then that's the result, right? Okay. So I think that's a pretty efficient way to either bootstrap a sample, works with any geom, any stat, right? All you need is these two functions, bootstrapper and sampler. And the nice thing is the bootstrapper, if you assign it to a variable, then you can reuse it multiple times in multiple layers, so they'll all bootstrap exactly the same way. If you look in the documentation, you can see how that works. So you could like draw lines and points or whatever on top of each other, and they'll all be bootstrapped exactly the same. Okay, but there's still this other thing, right? We can also generate outcomes by normal approximation to the sampling distribution. And I did some work on that also. And so I'll introduce that by comparing to the bootstrapping. So we'll go back to the motor cars example. So that was the example where we bootstrap. And now we have to write special stats or geom. So I wrote this stat smooth draws. So instead of geom smooth, now I'm using stat smooth draws. So that's like essentially a copy of stat smooth. So it draws a smooth line, but it does it multiple times. It samples from the posterior distribution. Now I don't have to feed it in the data, but I have to tell how many draws I want, right? So this is times equals 10. And I again have to set the group, but now because the draw column is generated by the stat itself, I have to write stat of draw. So here I write this because really it's the draw column is part of the data set that is fed in. Like it's kind of, it's done by this function, but to ggplot it looks like it's the data that it comes in, versus this is something that happens in the statistical transformation. And then these are the two plots, and they look kind of similar. If you do it enough, you can see that the bootstraps, they tend to be more grouped. You get like kind of sets of bootstraps that kind of look the same. In this particular plot, it's not that obvious, but conceptually it makes sense because bootstrap, you add or remove entire points, right? Either the point is there or it's not there. With the fitted draws, you smoothly sample the entire space of possibilities. And then this actually also works with gganimate. So gganimate understands that it can transition on columns that have been generated by the stat. And so then you get this. Okay, so just very quickly, because the people that invented hops care a lot about, so there's different ways that you could animate this, right? I've been using hard transitions. You could do hard transitions, but on a background of all the outcomes. I don't know if it's sort of visible, right? Okay. You could fade outcomes. This is not really, like, if you can sort of see it, they fade out and the new one comes in, or you can tween between outcomes. This here is actually the default that gganimate will do if you don't tell it otherwise. It looks very fancy, but the perception researchers argue that this doesn't really work as well so in psychology experiments, people have a harder time judging the uncertainty from these kinds of graphs than from these kinds of graphs. So it seems that the general consensus is this or this is the best way to do it. And that's really it. My take-home message is make hops, it's easy. This is the website, but since we have a little bit time left, there's a bonus. So this is just to show off, right? So there's a bootstrapping example where you actually see the individual dots, how often they've been resampled, right? So for example, if you look here, now it's 0, now it's 1, now it's 0, now it's 3, 1, right? And you see also when this one gets 0, the line ends, and now it's there again, right? And then when this turns to 0, the line, now it starts here, right? So this really visualizes how the bootstrap operates. And that's the code that does it. And so that's all you need for that, right? This is the trick here. I'm assigning this bootstrapper to an object, and then I'm using it here to draw points, here to draw text, and here to draw the bootstrap lines. And so they all see exactly the same bootstrap, right? And so that makes it easy to make really quite fancy visualizations, hopefully easily. That's all I have. Thank you.
Thanks, Claus. That was really cool. Any questions? We definitely have some time.
Back there.
Yeah, that's one back there.
This is really cool. Can you hear me? Is this okay?
Yeah.
I'm curious a little bit about how much we know about how much these work better, and about how well people are interpreting uncertainty out of these sorts of things.
So yeah, there's 2 research papers as far as I'm aware. So it's a really active research. In the 2 papers that have been published in direct comparisons where people had to judge like how uncertain something is from a hop versus some other visualization of uncertainty, generally people get a better sense of the uncertainty from the hop, and people are better at actually judging accurately what the chance, for example, is. I mean, like, you have to judge, are you getting the train or not? Like, what's the chance if you get a coffee now versus not that you're going to catch the train? And people do better with these hop type of uncertainties than just like error bars or something like that.
Another question? There's one up here.
Can you have confidence bands with animations?
Can you repeat?
Have confidence bands with animations, the standard error around the. So, for instance, the top right graph, you had all the possible lines. Can you also add the confidence bands to that?
Oh, yeah, I mean, it's just a plot, right?
Okay.
So you just layer them on top of each other. So you could use. So with the confidence band, there's this little subtle problem in the sense that if you use a geom smooth to draw the confidence band, it uses slightly different math from my geom stat smooth. Have to do a little more work, but it's like 3 additional lines, and it's shown in the vignettes that I wrote for the package. I mean, yeah, you just layer plot layers on top of each other, and you show whatever you want to show. Yeah.
Maybe one more. Okay, up in the front.
Thanks. Really cool talk. Just wondering, has anybody asked you about maybe incorporating p-values into this, bootstrapping visualization? And if somebody were to ask you about it, how would you respond?
So in my day job, I'm a scientist, I'm a biologist. I've seen lots of figures in my life. I've never seen a p-value visualization that I thought was useful or credible. So I really don't know. I mean, that doesn't mean it's not possible. It's just I've never seen it. I don't know how to visualize p-values in a way that is useful.